So our last two lessons have to do with calculations, and they're things that we have seen before. We're just going to put them together in a brand new way. So we're going to look at neutralization reactions. So when a acid and a base get together, they're going to go through what's called a neutralization. Um, so this neutralization happens when acid and base, these react and they make a salt and water. So remember that um, acids and bases, when they react, make salt and water, and our salt is our ionic compound. Okay. We can predict our products based on this. So this goes back to unit 4 when we were doing chemical reactions and predicting products. We know we're going to make a salt and we're going to make water. So in our example, we have nitric acid and potassium hydroxide. We know that this H is going to go with this OH to make water. That means the K has to go with the NO3. Remember, NO3 has to stay together because it's a polyatomic. And so we're just going to write that over there. And then, of course, if you need to, you have to balance your equation. Luckily for us, this equation is already balanced for us. Okay. So once we know what we're going to make, so we make our salt and our water, we can actually use this to go forward and with our balanced equation, because we are going to, if you remember, when we are moving from one compound to another in a reaction, okay, in a chemical equation, a chemical reaction, if we switch compounds, we need to go for our molar ratio, and our molar ratio is using our coefficients from our balanced equation. Told you balanced equations were coming back. You didn't believe me. So molar ratio. Okay, so here's my problem. How many moles of hydrochloric acid are needed to neutralize 3.5 moles of magnesium hydroxide? So here's my balanced equation. I have 2 HCl's plus magnesium hydroxide making magnesium chloride and 2 water molecules. Okay. So I'm going to do the same thing I've always done when I've had to deal with this whole changing over this stoichiometry. I'm going to make a T-chart. Okay, this doesn't really do it. In my upper left corner, I'm going to put my given, which is 3.5 moles of magnesium hydroxide. To get rid of magnesium hydroxide, I have to put it on the bottom of my T-chart or my fraction chart. Okay, and I'm going to put 1 because if we notice right here, there is no coefficient, but since I write it, I have to put 1. Okay, and then I'm going to put HCl because that's what I'm switching to because this is how many moles of it. And then I'm going to put 2 because I have a coefficient of 2. So I'm going to take 3.5 times 2 divided by 1, and it takes 7 moles of hydrochloric acid for me to neutralize this. Okay, so sometimes it's going to ask you for your moles, but it may ask you to go a little bit further. Okay, so once we know the number of moles, we can actually solve for the molarity of our compound. So if it takes 87 milliliters of a hydrochloric acid solution to neutralize 0.67 moles of magnesium hydroxide, what is the concentration? We're going to start off the same. I need to solve for the moles first of hydrochloric acid. So I'm going to make my chart. Okay. I'm going to put in my upper left corner 0.67 moles of magnesium hydroxide because that's what's given to me. Okay. To get rid of magnesium hydroxide, I'm going to put the moles from the balanced equation. So again, I'm going to look here, and I don't have a number, so it's 1. And I'm going to switch over to what I'm looking for, which they said we use hydrochloric acid solution to neutralize. So that's going to go on top. And again, I'm going to put my 2 because of the fact that there's 2 in my formula, in my equation. So I multiply across and divide by the bottom, and I get 1.3 moles of hydrochloric acid. Now, it's asking for molarity. So that's going to go back to Unit 9 when we actually did molarity, which is, remember, molarity equals the number of moles divided by the liters. Okay, so moles over liters. So my moles that come from my last problem, which is 1.3 moles. My liters, now note, in my problem, I have 87 milliliters. So I have to convert that to liters, which means I got to divide by 1,000. Okay, and I get 0.087 liters. If I divide 1.3 by 0.087, I get 15 molarity. So my hydrochloric acid is 15 molarity. And that is how you do neutralization reactions.